Hi everyone! This video looks at a weak acid titrated with a strong base, and will focus on the pH calculation after the equivalence point in the region where we have excess titrant. This is a situation where our titrant volume is more than 0 mils, which means we have to set up a millimole table. The E row of our millimole table tells us where we are on the titration curve and guides us as to how to calculate the pH from that information. In this generic millimole table, our E row shows us that the HA goes to 0, which means it has completely reacted. The OH minus is greater than 0, which means there is an excess or more than what was necessary to fully react with the acid. Because we started with a weak acid, we also form conjugate base, A minus. However, we can effectively ignore the A minus here. The reason is that the hydroxide produced by the equilibrium of A minus is much less than the direct contribution of the excess hydroxide. This situation puts the reaction progress in region 4 of the titration curve, which is after the equivalence point. To calculate pH after the equivalence point, we first have to calculate the hydroxide molarity. We get this by taking millimoles of OH minus from the E row and dividing by the total volume. We get the total volume by adding together the milliliters of acid and base given in the problem. Once we have hydroxide, we can calculate pOH by taking the negative log of the OH. Then we'll get pH by recognizing that pH plus pOH equals 14. Rearranging this equation gives us pH equals 14 minus pOH. The 14 is not exact. It comes from kW, which is a measured value. We use kW to 2 sig figs, which gives us 2 decimal places in 14.00. In our example, we see that we have more than 0 mils of titrant, which tells us that we have to set up a millimole table. Our reaction is the weak acid, HA, reacting with the titrant, hydroxide, to form the conjugate base, A minus. Our rows are I, C, E, initial, change, and end, and our units are millimoles. We need to calculate the millimoles to fill into this table. We'll start with HA. We have 12 milliliters of solution times the molarity of the HA, which is 0.0500 moles of HA per liter of solution. Liters of solution will cancel, and that will leave us with milli and moles. Looking at our sig figs, we have 4 sig figs in our volume, 3 sig figs in our molarity, so our calculation of millimoles will give us 3 sig figs. Doing the math, 12.00 times 0.0500 rounded to 3 sig figs gives us 0.600 millimoles of HA. Calculating millimoles of hydroxide, we have 10.74 milliliters of solution times the hydroxide molarity, which is 0.0800 moles of OH minus per liter of solution. Liters of solution will cancel, and we're left with milli and moles. For the sig figs, we have 4 sig figs in our volume, 3 sig figs in our molarity, so our millimoles will also be rounded to 3 sig figs. Doing the math, we have 10.74 times 0.0800 rounded to 3 sig figs gives us 0.859 millimoles of OH minus. Now we can enter these values into our millimole table. We have 0.600 for HA, 0.859 for OH minus, and 0 for A minus. We always subtract the smaller number. In this case, that's the 0.6, so we subtract 0.600. Make sure you're writing all the zeros because we need to be able to keep track of the sig figs from the subtraction in the E row. So that's minus 0.600 for HA, minus 0.600 for OH minus, and plus 0.600 for A minus. The HA goes to 0. Our hydroxide, 0.859 minus 0.600, gives us 0.259 millimoles, and our A minus is at 0.600. Let's evaluate the E row of our millimole table. We have no HA remaining, but we do have titrant, which tells us we have excess titrant, and that is after the equivalence point. To do the calculation of pH, we need to calculate the hydroxide molarity, and we get that from the millimoles, 0.259 millimoles of hydroxide, divided by the total volume, which is 12.00 plus 10.74. The millis will cancel, and we're left with moles over liters, which is molarity. For our sig figs, we have 3 sig figs in the numerator. We will have 4 sig figs in the denominator after we do that addition. So our final calculation of molarity will be rounded to 3 sig figs. Doing the math, 0.259 divided by 22.74 rounded to 3 sig figs gives us 0.0114 molar OH minus. We can then calculate POH, which is the negative log of the OH. So we take the negative log of 0.0114. Because our log term has 3 sig figs, our POH will end up having 3 decimal places. So taking the negative log of 0.0114, we get a POH of 1.943. And then our last step is to calculate the pH, and we get that by taking 14.00 minus the POH, 1.943. Notice here that our 14 only has 2 decimal places. So even though we did have 3 decimal places in our POH, our final result gets rounded to the fewest number, which will be 2 decimal places. So doing the subtraction, 14.00 minus 1.943, we get a pH of 12.06.